So Marinko, are you nervous? No.
Oh, why should I?
Just asking to break the silence. So I would say without further ado, we should more or less start with this presentation. If anyone joins us after this, well, yeah, they will be able to see the recording. Thanks everyone for joining this meetup organized by Data Science Macedonia. As we mentioned last time, the idea is that we step up with these events. We are all aware that we are not able to organize events with public presence, so to see each other in person, but this is the next best thing. So for this week, we organized an event related to Oracle stack, and we have a person that's really passionate about Oracle. That's Marinko, who will introduce himself in a bit. And I just want to add that next week we are going to organize another meetup. You will be duly informed in the next 2 days, I would say. And again, if anyone from the community has interest or wants to share ideas on some topic, please make sure to contact us, the organizers, so we prepare and organize a meetup. And looking forward to this presentation and to questions. So I will switch off myself in a minute with the camera, leave all the space for Marinko. Nevertheless, if you have a suggestion or question or want to comment anything, just use the chat after the presentations. We'll ask questions and continue with the discussion. So Marinko, the floor is yours.
Thank you, Goran. Hi, my name is Marinko Kovevski. I'm senior software engineer at Scale Focus. And today I'm going to talk about Oracle Autonomous Databases. So these are new databases. No, it's not. This database exists from 20. In the last 3 years, it is upgraded with many new features, but mainly we can say it's driven by machine learning algorithms. So Oracle extract best engineering practices from various fields like system malfunction, first line support, or DB optimization techniques, and gathered all together, they form one product that is one of the best in the market. All of these features are applied in the background, so they can hold the database to be up and running. This presentation has 2 parts. First is a little theoretic about Oracle Cloud infrastructure, and the second one is practical example. So let's start. Who am I? I'm Marinko, Oracle Certified Professional. These 3 certificates are relevant for this topic. First one is OCP, Oracle Certified Professional. Is a 3-level certificate, very hard to achieve. Second one is Oracle Certified Associate Java Developer. And the third one is Oracle Certified Specialist for Cloud Databases. So if you have any questions, below is my email. You can write your situation. I will try to answer the best possible solution. So as first, let's see the situation on the market. For me, Gartner is a relevant institution for market analysis. And as of October, here you can see that Oracle is leading in the market in terms of completeness and of vision. But AWS, Microsoft, Azure, or Google may have a better ability to execute, but Oracle is better in completeness of vision. What is Oracle Autonomous Database? Is a stack of 3 pillars. One is complete infrastructure automation. Another is complete database automation and Center for Operations and Machine Learning. So Oracle builds their own Exadata system that is a specially designed machine like Apple products. They developed their own machine optimized for using their Oracle database, and they developed their operating system, Oracle Linux. So the second pillar is a complete database automation. This is product developed since 1979. In the last 40 years, they gathered all the positive feature and put it in one product. I must say, it is backward compatible, so you can easily run your father code there and probably will go without any exceptions or errors. And the third new pillar is machine learning. In terms of machine learning for database automation and managing, and in terms of data science and data discovery, data analytics. Oracle infrastructure is divided into regions. Some of those regions are divided, are shared by Microsoft Azure and Oracle, but many of them are 100% Oracle. In every region, we have more availability domains, and in every availability domain, we have 3 fault domains. So you can see one fault domain as one rack here, like complete infrastructure automation. So if any of these rack fails, the other 2 will take over the job. And if a whole availability domain fails, the other 2 will take over the control and get the job done. So this is how they achieve high availability. How the database is automated. It is automated by provisioning, security, and management. Let's say for provisioning, you can set your limits with hardware resources, and at the end of the day, you're using Exadata. You're using a real application cluster, and the database scales itself depending on the load. On the other side, you have security concerns about encryption of the data at the storage level. So the data, we can say, is secure. Also, we have SSL connections and audit logs for SSL access to database. And the third pillar, management, is automating the whole business process of managing a database. When we let the Oracle to do the operating system maintenance, system patching, database patching, diagnosing errors, they diagnose disk latency. So if some disk shows signs of they immediately switch with some hot backup. There are 2 types of autonomous database, data warehouse and transaction processing. They're totally different in the structure and using the same infrastructure. In terms of primary goal, we have at data warehouse, we have fast complex analytics, and in ATP, we have fast transaction processing. That means when you're learning about databases, you're learning that there are 2 types, OLTP and OLAP, and these are those 2 types. So in data warehouse, the data is stored in columnar format, and in transaction processing is stored in rows. On one side, data warehouse is optimized for parallel joins and aggregation. And for transaction processing, the data is optimize for data caching and avoiding I/O. So in ATP, you should have system that responds in less than a second. If your response is more than 1 second, probably something is going wrong, and you should consider what is happening on that database. What is common for these two types is that Oracle managed statistics in the two types of database and optimize automatically. In these types of database, we have different type of consumer groups. So high means that you're using all the resources, and the low means that you're somewhere in the queue and will be executed when you will be on place. So one connection with high consumer group has the highest resources, can query in parallel, can do all the job done with the all resources. Medium is a level down, and the low is serial processing with no execution of more than 2 CPUs. On the ATP, they add new consumer group, TP urgent and TP, that is for transaction processing, which means database use all of the resources in terms of transaction processing, not in terms of all of resources. And those below high, medium, and low are almost the same as ADW. Medium and low are usually for reporting and batch processing. Oracle can gather data from different resources like AWS, Azure, Google Object Storage, and it's not a problem to fetch data from anywhere. You can fetch from your local PC or from anywhere from the cloud. For data integration, they have built tools like Golden Gate, Data Integrator, and Data Integration OCI, but you can use any other tool that provides the same work. On the other hand, for business analysis, they have Oracle Analytics Cloud, but you can use any other tool that can get the job done. So we can say this database is open. One of the main features in this database is automatic indexing methodology. So every SQL that executes in the database has their own SQL ID. And this database tries to build a bridge between 2 points every time when you hit run of your select statement. Probably the database have more path how to execute this travel, but in every single time the database tries to find a new bridge between those 2 points. So system makes some fork of that process, and in background process system try to validate if the system has new and better results. He applies all of that logic in front of the database. This is example how this process work in background. The process tried to capture what is happening on the database level and to identify what is the problem of that event. After identification, the system tries to verify different possible paths of execution. And if those paths of execution are better than the production one, system decides to deploy that model and monitor the system again. And this process goes in circle for infinity. So on the right side, we have graph. We have a picture that shows the load of database. The first time we see that system is using 6 cores of CPU, and after a while, when system this process analyzes the whole situations, is deciding to create 43 new indexes, and after building those indexes, after 30 minutes of workload, the system CPU reduce the size of 2 cores CPUs. So the database itself makes decisions how to reduce the CPU. And as you know, the CPU is the most expensive resource when you're providing the database. And another important thing is when you're providing your instance, these CPUs can be scaled automatically. So you can set the upper limit and let the system decide when to use 2 CPUs and when to use 6 or more. These are the resources for you're trying this Oracle database. You can try your code on Oracle Live SQL. This is the portal built for developers who want to see and try some code. You don't need to deploy your own instance of database. You just need to hit and run this code. Everything that you need is email address, and you can start code here. Now let's talk about the database and Oracle Cloud Infrastructure itself. As you see, this account is free. It's always free, free tier account. I'm not paying for this account, and some of these features are disabled because they're paid. So in the menu, I choose the ATP type of database. On the other side, I have a paid account in Zurich, Switzerland. This is also demo account that is activated before 2 or 3 days. On the right side, you can see your budget. When you create your account, you have 250 euros free bill that you can try many things on this type of database. So as you see, I have one instance that is running right now. I am using 20 gigabytes of storage and 1 CPU. You can also create your container database and your Exadata infrastructure. This Exadata infrastructure is the most resourceful database. Let's see some example here. As you see, you can choose on what availability domain you're building your instance. And these are the configurations that are allowed. You can order quarter rack with 100 CPUs and 150 terabytes of data, half rack and full rack. So these are very big databases. Those are the most resourceful. Now I will open this database, which is always free, and you can build your own database. like this, and they will not charge you. As you see, the version is 21C, is always the latest version, and the latest patch. You don't think about database administration. Here you have a database connection where you can download your instance wallet. Sorry. In the wallet, we have these types of service providers that I have shown before. This is high, low, TP, and TP urgent. So you can access your database with different types of connections. Now, after this, I have a performance hub, which is somehow like a task manager for this database. You can monitor all things that happen on this database. ASH stands for Active Session Analytics. You can see what SQL is going on right now, or monitor your session, monitor your workload, or you can see the blocking sessions. So when you're operating with your database, it is almost possible to lock some sessions between, especially when people are working with their applications. The possibility of locking is very high. Here is the service console. In the service console, you can manage your database resources. As you see, you have some overview how much of your storage is used, what is the activity on the database level, administration to download your client for accessing your database, manage ML users, part when you're creating database users for machine learning techniques, and development section that cover database actions and Oracle machine learning notebooks. In database actions is a traditional action panel that can access all of these resources. Like you see, you can write your own SQL statements, and you can REST enable your database. This is one new feature. You can make your own table and auto REST that table. Open that database for outside of the world. These three auto REST, let's say we have stock price for Apple, and we can REST access this data here. You can add your authorization header and accessing by ID of this data. Also, now I'm going to show you a demo about Jupyter Notebook and how to manage with your Oracle data. So here you have you need to download your Oracle client and download your wallet, and after that you can set up your connection string, and done, you have connection to your database. When you're working with the data, probably the data will not be in one table and in one database type. So you have to be, you must know what is going on with all of these features in order to achieve successful data manipulations. Here I'm using, I'm trying to show you that you can make your own table with a column of XML type. You deal with XML a lot, so probably you could fit your XML data somewhere in the table. So, and the limit for this can be gigabyte of data per row. And if you store gigabyte per row, it will work, but probably is a sign of bad design. So here I'm inserting this XML into this table and fetching this table, this XML again. Also, at this database you have blob and CLOB. This stands for binary large object and character large object. So you can make your tables with columns of type pictures, or even you can put your Blu-ray movie in one single row. Again, probably bad design if you're putting movies in every single row of your tables. JSON, you deal with a lot of JSON data, so you can make your table with column type of JSON. And there is a bunch of APIs built in Oracle database that can deal with XML nodes, binary large data, or deal with JSON data. Another option is row level security and virtual private database. So probably with your company, some of your people are forbidden to see some of these features. So when you're seeing some table and you're logging with admin user, you can see all of that data. But when you're any other user admin is, you won't see the information about volume. Also, you can filter the rows of these tables, and it's a nice way to implement segregation of duties, so no one will see nothing is if it is not authorized. How this is done? On Oracle level, you have packages. That is a unique feature for Oracle. In those packages, you can put your own functions and procedures. So when you're executing this select and insert statements, these predicates are executed. I put some context information in, and when some predicate should see this predicate is always true, and if should not predicate is always false. I just run dbms rls package dot add policy to insert this predicate, and the job is done. You cannot see the data here. Another important feature is addition. So what are additions? Let's say you have functions or procedures or everything else. You can have package body or trigger types or many of those types of products, and make a fork of that session. So when you're executing your session, you're forking that session in parallel. So you have a Schrödinger cat story. One object, two possible states. And it's a nice feature to see how things will work if you did some changes in the production environments, for example. So you can easily switch between those sessions and go in nested levels as many as you want. Another important feature is from 21C is blockchain tables. So you can create your own blockchain table that contains only four columns: ID, fruit quantity, and created date. And Oracle automatically will add these columns for managing this type of tables. So when you're selecting, everything is fine. When you're inserting, everything is fine. If you try to update some of this data, it ends up with this error. Operation is not allowed on the blockchain table. Same happens when you're deleting one table, delete some rows of this table, or even when you try to truncate this table. You can achieve this with trigger and some history tables, but triggers can easily be disabled, and none of this feature will work like expected. So it's a good mechanism for dealing with data that must be added, not modified. And the last but not least are objects. In Oracle, you can make your own objects. And instead of doing insert into statement, blah, 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 you can make your object and you can call the insert method there. And you can change that object and call the update method. Behind this object is standing one table. So basically you're doing just creation of one table type, and everything is done on this object level. So it's a nice feature when you're working with large, very big business logic. Now I'm gonna show you another instance, and I'm gonna show you the machine learning part from this service console. I will open machine learning notebooks. For this purpose, before I create a database user ML3, And as you see, you have section of how to do something, AutoML feature, notebook, and job that can execute this kind of notebooks at a certain period of time. I will try to open AutoML and create a new experiment. Let's say experiment 1404. Now I have to choose one database. I will choose ETH price. This data set is price of Ethereum and history of the price of Ethereum. All of these columns are almost every is a number. It's close value, high value, low value, market capitalization, open value, serial number, and the volume of these transactions. You can set the target that you want to predict. So let's say you want to predict the volume of the Ethereum. The uniqueness of this dataset is serial number. And in additional settings, you can set the number of top models, maximum duration hours. We're not gonna wait 8 hours for execution. And I can set a high level of service to use all of these database resources for data analysis. As you see, when I choose what to predict, the system by itself choose that will do regression, and some of the algorithm you can turn off of if you don't like to analyze one of them. And I suppose I can run this. As you see, I can run for faster results and or for better accuracy. Let's say I want to run with the faster results, and now the experiment is creating. I hope that will run like it should. On the other side, I can open this performance hub to see what is going on. Yes. Oh, it's running. As you see, now is working algorithm selection. And different type of algorithms has different generic names. It is working right now, and is trying to sort this result with the better as first. The bunch of background processes are happening right now, and this chart shows that we achieve 84% of correctness. Just to, okay, it's done. It's completed, I think. Yes, completed. So now these are the results. I can see the results and see that market capitalization is with highest prediction impact, and they are sorted in descending order. I can select one of these models and create a notebook. right? So I'm naming like data science. Let's do this. Yes, this notebook is created in the notebook session. Now I can see this notebook. In the background, system is firing up notebook server. Right. So this notebook is generated by Oracle and is divided into sections: build data, train data, do the model, show details, show accuracy, everything that you need to see what is going on behind this AutoML. So you can make your own corrections here if you want to change something. For example, it's not a problem. And just because this session is using notebook server, the page is not so quick for switching between those two sessions. Normally, if you're going professional with this, probably you will build your own virtual machine for notebooks. And if I choose the one of these models, I can deploy this model. Let's say DS where I version 1.0 with the namespace. Okay. And the model is deployed. So hopefully I will open that model section. Let's go. Try to open models. Do I have another session? And when I deploy this model on this ML module, this module is available for REST calls. So you can use right when your model is deployed. You can ask some question if you.
Yeah, Marinko, I just wanted to jump in while we're waiting to break the silence. So Blago Jankovski has a question for you. So the question is, can we code our ML model, or it should be selected from the predefined options only?
Yes, you can run your own ML model, as you see in the notebook sessions. In the notebook session, you can intervene on these auto-generated models. So you're not restricted just what Oracle says. You can do what you need, what you think is important.
And nevertheless, but when you do the initial analysis, or so to say, that some kind of grid search, which is from machine learning point of view, what Oracle does automatically, you're not able to provide any settings other than what you just showed us on the page. So just better accuracy, better option, or several drop-down menus and selection of models, but you're not able to specify parameters for specific models. That is only possible after you select a model and create a notebook from that model. Is my understanding correct?
Oracle has built their own OML library. So if you search for that OML, it stands for Oracle Machine Learning Libraries, OML, GitHub. There are several examples about these topics. So probably you should think more about this, research this UI and see what is going on behind this OML. Like you see in the previous example, you have import OML that stands for Oracle Machine Learning. And I think this section should be revisited.
Yeah, that's a great resource for us to share with people, and I will just share that link in the comments so everyone on this call will be able to see it and get it. But I know that you're very passionate about Oracle. What I can see here, I really see the utility of auto ML for people who are working with databases, just in order to find important relations between the data within a table. My question is a little bit broader. So are you aware of tools, similar tools that operate on different databases? Or this is something that's very specific to Oracle, or maybe you're not working with other databases, so that's also fine.
Oracle has their own infrastructure, their own tools. You cannot use some generic tool that is provided for example, for PostgreSQL. So as you see, Oracle has packages, has object-oriented programming, has different features that are not even talked about on the other types of databases. So that's why Oracle is very strict and is one-way street with that type of questions. They have their own tools for data maintenance, for data accessing. One of most important tool is Oracle SQL Developer. this SQL developer is built and provided by Oracle without paying for this. This is free tool. And about data integration, you have Oracle Data Integrator and Data Modeler, Oracle Studio, JDeveloper. There are a bunch of tools that can be used, but they are specific for Oracle. Maybe MySQL will be used in some cases, but they are specific for Oracle.
Yeah, closed ecosystem for sure has advantages and disadvantages, of course, as everything. So as a follow-up question, since you're very passionate about Oracle, from me to you is, in which situation Oracle is the absolutely must go with choice? And which are the problems where people should say, okay, this is not for Oracle, let's go with something else? Can you make a very tight distinction between these two cases?
Yes. Actually, I have one example for that, but we don't have time for this. For this show up, I have one table that has 6 billion rows, not 6 million, 6 billion rows, and weights over terabytes. So when I try to join these tables, and Cartesian product of this can be petabytes, let's say for 30 million customers and 6 billions of line order items, the result is almost 20 seconds. So if you're dealing with a large data set that weighs terabytes of data, you must go with Oracle. You must. There is no other product on the market that can deal so fast as Oracle can. But if you're dealing with 100 rows or 1,000 or maybe 100,000 rows, probably you have cheaper versions and you don't need this adventure.
Yeah, in a nutshell, I think that people got the point when to search for an Oracle solution, or when to just go with some other provider based on the budget and based on the the size of the data set, I would say. So before we close, do you have anything, Marinko, to add? Just some anecdote from your working experience with Oracle, some short example that you want to share with everyone?
No, I think I say enough with this. I think they should try with Oracle. This is always free tier. Nobody will take your money. Just spend some time with this and you will see that it's totally different from any other product.
Yes, for sure. I'm really impressed with what Oracle has done. Definitely, I will try it myself. So everyone who's on the call, if you have any interest in the Oracle database, please feel free to create an account. I think that's for, as Marinko said, there is no cost associated, and you can play a little bit with their auto ML. I don't know what's the maximum size of the data set that on a free tier you can play with.
You have 250 euros for the first month. So for the first month, you can set very large data. Let's say 10 terabytes of data. You can run it.
That's great.
It's not a problem. You can run it. For instance, here I have 8 cores, 8 CPU cores, and 1 terabyte of data. and this costs me, this is paid version and costs me only €1 per 2 hours, like 50 cents per hour. So it's when you're talking about cloud computing, you should think as of somewhere else computer. So you probably will think twice how much will you use, and your bill will correlate with those usage.
Yeah, I've heard the security guys say the same. So there is no cloud computer, only someone else's computer. Marinko, again, thank you very much. I think that this was very interesting. As I said, everything is recorded and we are going to share this with anyone who's interested. If you guys have any follow-up questions, feel free to contact Marinko on the email he provided or me directly. If not, I just want to wish you a nice rest of the day and enjoy and tune in for more meetup and more tech stuff in the weeks to follow. Have a great day, guys. Bye bye from me.
Bye bye from me also. Have a great day.